When an object is immersed in water, it displaces its own volume of the water. One can measure the volume of an object by immersing it in water in a graduated container and measuring the rise. But a more accurate method utilizes a balance to measure the mass of the displaced water. Here is a beaker of water on a triple beam balance. The slides have been adjusted and can read the mass of the beaker and water. Here we wish to measure the volume of a rock. It hangs from a thin string next to the beaker. Its height is set so that when immersed in the water, it will be completely submerged without touching the bottom of the beaker. When the rock is immersed, care is taken to prevent it from touching the sides of the beaker. The water rises in the beaker, an amount equal to the volume of the rock. The scale also unbalances. The additional downward force on the platform is equivalent to the mass of the displaced water. Now we rebalance, and the difference between the new reading and the original reading is the mass of the displaced water. Some bubbles cling to the rock, causing a displacement that is greater than the rock's volume. By tapping it lightly, the bubbles are knocked off. The mass reading is lowered by about 1/10 gram. Because water's density is by definition 1 gram per cubic centimeter, the gram mass is also the volume in cc's. By measuring the mass of the rock itself and dividing this mass by the mass of the displaced water, the rock's specific gravity can be determined.